year's Nobel Prize today.
Dark energy is the coolest part of the universe. Dark energy isn't even a particle, it's a truly new kind of stuff. What it does is push things apart rather than hold them together.
Galaxies are moving apart from one another.
I was watching One Ancient Alien. It was talking about the day kind of invented two elements.
Gravity would see that.
It was like 115. Yeah. And it was like the one guy he's like conspiracy guy told everybody about it.
He stole some of it, Bob.
Yeah.
Yeah.
And then it turns out that, like 20, 30 years later, there is none.
No, we've discovered it now. Yeah, but we can only make small amounts of it. So however they were doing it, like the aliens.
Understanding the dark energy problem will allow us to unlock this secret of the universe.
But they probably got up like
Things like
370.
teleportation may become a reality.
But it's supposed to be what they make rocket or like inner.
That's what controls the gravity manipulation that helps them go through the galaxy.
Some kind of weird shit.
Yeah.
When you use it, you can fold space.
And you roll downhill, so that's how you can travel without expending energy. That's how they get across great distances quicker. You basically create a little
far more advanced than even Earth's most cutting-edge dark energy telescope, the DE camera.
Here's what's cool about
A
the
couple
dark
of them swung at me too.
Big telescopes are rare.
Rosie, when we were chasing the one cow, she was like biting it on the nose, and it like charged her and pushed her into the mud on the side of the creek, like smushed out with the mud. She got up and was like, I'm done. Like, I'm too old for this shit. It was totally like, well, that fucking hurt. Yeah, I'll be back in the house.
It's going to help us to measure how much dark energy
She was like wants to get involved so much, like she knows we're chasing the cows and she's been watching us do it, but she doesn't know what to do. Right. She just chases them.
The DE camera will be able to monitor the indirect effects of dark energy, not
the vet's always like, why don't you put that dog in the house? And we're like, she'll fucking claw her way through the wall to get out.
The substance.
We need to like have her on a rope or something. But I guess like all the cows have been getting pregnant, so they're like drawing blood. And maybe the bull's sterile or something.
Behind closed doors, diplomats maneuver to curry favor with China.
China
It is the worst possible moment for a spot in international
cancer,
tension.
I guess.
I'd like to think that the discovery of some practical application for dark energy would bring countries and people closer together. Unfortunately, that's the sort of discovery that tends to become proprietary. This was the problem with the discovery of nuclear energy. It didn't bring people closer together. If anything, it drove them further apart.
If the aliens have mastered dark energy, they could use it against us. Are the aliens overhead, preparing to obliterate us all over the world? The vessels maintain breathtaking alignment.
It may not be that we're talking to specific beings with encapsulated intelligence. Much more likely, in my view, that it would be some sort of hive or some sort of distributed or collective type of intelligence.
Something's just wrong with this.
Hive mind is an intelligence where the whole is greater than the sum of the parts. Everything is devoted to the success of the collective. It's communism without the corruption.
For survival or warfare on a grand scale, few things are more effective than hive intelligence. It turns fish into ultra-efficient hunters, stars into stealth bombers, and ants into architects. And the army of machines swarming our planet seems to possess similar powers.
It's entirely possible that a hive mind could develop interstellar travel much more quickly than we could. You wouldn't have a situation where you have different scientists, different engineers competing with different ideas. There's no dissension.
No matter where people are on Earth, they all see the same synchronized display, many of them reported to the cloud.
Sometimes when I'm sitting on the bus and I see all the young folks with their cell phones, talking to one another, texting to one another, I say, the hive mind is here. We're sharing information, but we're also sharing experiences. So in some sense, we're interconnecting ourselves in a way it wasn't even conceivable a century ago.
I don't know what you would call Google. Google is some sort of gigantic throbbing megabrain that's living or non-living.
Smart laws are groups of individuals all over the planet pooling their resources suddenly to solve a problem or to prevent something. These ad hoc groups may be a sign of things to come.
Or a sign of what's already here. At USC's Polymorphic Robotics Lab, Dr. Wei-Min Shen and his team are experimenting with a new generation of multi-purpose robots, capable of working alone or in a swarm. One day, these bots may help prepare new
They already
worlds
hit
for
roads
human
that work like
colonization.
that.
Each individual module
They
you
can
can use as
do
a single cell.
Faces, bird
When
guy,
they get
bird,
together,
that's
they
what
become
birds are.
multi-cell organisms and suddenly become
They can
much
do
more
like
powerful.
synchronized
In nature, an ant swarm is brilliant.
crazy shit.
An ant on its own, not so much. These robots can think for themselves or for the collective.
They have their own brains. You cut it in half,
Oh, that's
every
great.
one of them, whatever you cut, the first one will become the brain.
Today, we see engineers building systems that can go around and do things all on their own, act individually. Then they can come together to form a collective that's even more powerful.
Swarms of smart robots may soon become very useful to us as scouts or even colonists on distant planets. They'll map the terrain, plant seeds, then turn themselves into greenhouses to protect those seeds.
So they go out to explore the environment while they dig, looking for material. Maybe day after they build houses or shelters.
Such actions would be peaceful on an uninhabited planet. But Earth is already our home. What do the aliens want with our planet? Do they want to meet us or destroy us? When the light dissipates, the vessels are gone. But they had left something behind. Our first contact with an alien species ends with questions. In the form of thousands of shining, jagged spheres strewn all over the planet.
People are always afraid of what they don't understand. But there will always be some fool who will pick up a lip balm and say, this is interesting, and it will go off in your hands.
Beyond the notion of actual alien visitors, there's so many other possibilities, like alien probes, artificial intelligences. We would have to be cautious.
All over the globe, governments struggle to control the situation. The streets of America look like a war zone as the National Guard, CDC, and local police search out and seize the alien objects.
Governments like to control things. But the great thing about having thousands and thousands of objects dispersed all over the planet is that there is no way these can be controlled. Perhaps that's why the aliens do it that way.
Even if the spheres aren't intended to harm us, they could unleash devastation.
There's the possibility of being infected by alien microbes. NASA has a planetary protection office to worry about that.
40 years ago, the Planetary Protection Office quarantined the Apollo astronauts for 3 weeks after their trip to the moon, just in case. But today, there is no protocol for the threat we face.
It doesn't necessarily take giant lasers and bombs. Microorganisms would probably be the best way of wiping out life on the planet. Any alien species that develops the ability to go from star system to star system, it would be really easy for them to develop microorganisms that could target whatever species they wish based on their own species biology.
In a sterile lab, biologists find no sign of toxins or recognizable dangerous microbes, at least on the outside. Figuring out what's on the inside is another story. Scientists can't penetrate the sphere's outer shell. They run every test they know.
One important test would be mass spectroscopy that helps identify all the molecules. This could tell you things like, is the material organic? Does it have biochemicals? Is it made of metalloid substance?
Based on techniques like this, biologists determine the sphere's shell is made of an ultra-hard yet lightweight carbon composite, a substance found nowhere on Earth. But it might be a sign of things to come, the archaeology of our future.
We run into an alien civilization that has an advanced technology that is going to be a roadmap of where our technology can go.
Throughout human history, we've invented materials and technologies that could be used for harm or for good.
The Chinese had gunpowder and used it for fireworks when the Europeans got hold of it. Cannons.
Yes, we've invented weapons and technologies that could be very deleterious to our future. But, at the same time we did that, we also invented things like rockets that within 100 years or 200 years will allow some of us to get off the planet.
Scientists suspect they may be looking at material advanced enough to change the way we engineer our world, from computers to skyscrapers, or even take us to the stars. It's the kind of material humans are trying to invent today.
Space travel in the future will be made possible by new materials that are extremely light and extremely strong. We still build stuff out of natural materials, iron, steel, wood, whatever. But we're at the point now where we can engineer new materials, 100 times stronger, 1,000 times stronger than steel.
We now have materials that can do things that we've never done before. These new micro-lattice structures, for example, are very strong and they're very light. Some of these new materials can generate energy. For example, a type of clothing that just by your very movement can power your cell phone or your watch. These things are things that are being made.
That's pretty dope. It's basically some clothes that have some technology in it where your movement creates like a charge that you can like charge your phone with.
The kind of materials that could someday revolutionize space travel.
Our material is constant boride. This is the hardest synthetic metal, the hardest metal that matter.
This super metal can scratch the hardest natural substance we know of, diamonds.
It's a really old method for mixing, kind of like the alchemy of the 1700s, but using a super simple method, we're making a super hard material.
A 5,400 degree flame fuses the tungsten and boride powders into a super metal.
So, what you got here It's the hardest metal known to man.
One of the most difficult things about space travel is weight. And so as you make stronger and lighter materials, it takes less energy to put them into space. It makes space travel more likely.
As we stare up at the mothership, are we peering into our own future? Is the material encasing the spheres a bright glimpse of what's to come, or a harsh of the end? Still silent and seeming tight. The spheres offer no clear answer. People continue discovering them in new locations. If they're bombed, why haven't they gone up? If eggs, when will they hatch? And then, suddenly, they start to come apart. Where before there was one sphere, suddenly there are several. It happens in a split second. The shells shatter to dust and fragments, revealing 2 to 4 smaller spheres inside, like seeds. This mechanism mimics certain plants on Earth, like the Himalayan balsam, which explodes open in order to sow its seeds.
Dispersion is a fundamental principle of life because without dispersing, then you're limited to what you have in a given place. All life forms have to disperse in some way in order to gain access to
It rose up, so I went to try to refresh it. And just
Unlike the seeds in an Earth plant,
showing up.
each of these alien seeds contains more seeds, and on, and on.
It's not showing up right now. It's supposed to be.
Each new sphere is a small, identical version of the one that's wrong.
It keeps happening. It's like the
The
third.
pattern echoes a phenomenon that's intrigued mathematicians for
Yeah,
centuries.
that's what it was.
Fractals.
Fractals are mathematical objects that have the interesting property of when you zoom up on them, they look the same as what they did before.
Is it the first camera?
The small box, yeah.
One small part of that.
So that one.
And what you get
Yeah.
is a magnificently endless universe that you can dive into and find self-repeating systems of infinite variety.
I've actually got. No, it's probably way longer than just the IP. I've got the IP copied.
These spheres could be like nightmares that just don't end. Because one thing is clear. In their smaller fractal state, the spheres are making it easier to move, to pick up speed, to spread.
It changed.
The IP.
These are entities.
Oh,
that
wow.
competitive, are
Just
waiting
right in the middle like that?
processes we have had to go through. Were they not creatures of such a process, we likely wouldn't even encounter. It's this impulse to go beyond.
Oh, okay. I was gonna say that's weird that it didn't pull that one up like it knew it wasn't supposed to.
As the spheres continue to multiply faster and faster, it's getting harder to.
So did it? I think this probably jumped IPs. This camera did. So now it'll be like the hunt to figure out what address
I
it
can get
is.
it back up.
Did you set the? Did you just say something about setting the one to static IP?
Yeah, this is turned on.
It should be. Is it not?
Give me just a second. I'll get it back up.
Cool.
3 days after an alien mothership deposited enigmatic spheres on Earth, the planet has been overrun. There were hundreds of thousands of them. Now, there are millions. These mysterious objects are 20 times smaller than when we arrived, and getting smaller each time they reproduce. The smaller they get, the harder it is to control. How small will these spheres be when they're done splitting?
The great Nobel
Yeah, you're right. With water in it, it's totally fine. That bubbler. But now I'm like, do I need to set it out there?
Getting small
Hope they just
is
don't
going
knock
to
it
make a
over.
big difference in the future. Nanotechnology is now one of the major frontiers.
A nanometer is 1/1000th of a meter, the width of a few atoms placed side by side, or about 100,000 times thinner than a human hair.
So it's conceivable that you could build machinery in the future so small that they're like dust.
People are talking about emulating viruses where the nanomachines would then go into the cell and possibly repair the damaged DNA so that the DNA in our cells will live longer, extending human lifespan indefinitely.
Because of nanotechnology, our computers will all be built into everything around us. From our clothing to our glasses will be completely interconnected with our surroundings.
So look, that's what we need is compare a video so that you can just live stream
Alien technology
push the button back, right?
is connecting with us.
Or record videos.
The fragmented spheres have started to attach themselves to things and people, and they're not letting go.
Say you're a living creature, you suddenly find yourself in a new environment. What are your opportunities? You could, again, attach yourself or invade.
We don't like other human beings invading our personal space. An alien object would do it. I think you would have a lot of people panic, even though the object hadn't done anything.
The fragments don't penetrate the skin. They only cause harm when people panic and try to remove them. And when they do fall, they leave no mark behind.
That shit would be
In
weird.
labs around the
Like a
world,
psychological game in that
biologists recognize the grip of these objects. It's oddly similar to one of nature's most remarkable adhesives, the foot of a gecko. The average gecko weighs about 5 ounces, but the sticking power of its tiny feet is enough to carry a 9-pound weight up a wall. About the same as a 160-pound.
So like, did they like attach a weight to a gecko and force it to climb up a wall and figure that out?
Perhaps the best designer of all is nature itself. And we human beings do well to mimic nature in order to build technologies for ourselves.
Inspired by the gecko's anatomy, researchers at the University of Massachusetts created a fabric called geckskin. The material is so strong, an index card-sized piece can lift 700 pounds.
There are lessons to be learned from nature. You sort of think, well, why is that? Nature is an engineer, but nature is an engineer.
The Earth is a 3.8 billion year laboratory of what works and what doesn't.
The first battery was inspired by drawing the electric organ of a fish. I can imagine an advanced civilization that merged machine and biology in ways that are incredibly complicated and sophisticated.
That guy runs
Are
robot
fast-spreading
legs.
fractals, a melding of
Well,
nature
he runs
technology.
robot legs. You could tell. He's like, I study cyborgs because I want to be
A
one.
name for a type of physics that grabs onto surfaces in order to disperse its seeds far and wide.
The capsules might be a form of test. And they might not do anything at all. How we react to this invasion could determine for the aliens whether we're worth talking to, whether there's any point in returning to this planet at all.
We will inevitably make mistakes with these solid occupiers. as humans do every day. Right now, all we can do is try to fix the problems we know how to fix. It sent us messages on its way from the edge of our solar system. But since its arrival, the mothership has been radio silent. Earth wants answers. It's time to reach the mothership. Thousands of self-dividing alien spheres have become millions. While 500 miles away, their mothership remains silent.
If it seems to be a derelict, can we claim it? If it seems not to be responding, could it be that someone aboard needs help?
Satellites monitor the giant ship's every move. Scientists beam message after message. We strain for a response, a sign, a clue. Nothing.
What if the aliens don't want to talk? Maybe if they just want to have a look around and leave. That would be almost heartbreaking. We wouldn't know where they were from. We wouldn't know how to contact them. We might spend the rest of our existence as a species trying to find the alien intelligence that once contacted us and never bothered to contact us again.
We need answers.
Telescopes will only miss so much. So in the next stages, we send our technology, our spacecraft.
The decision was made to mount an exploratory mission immediately. The rover's name is the Ambassador. His mission is to penetrate the mothership and gather data about the beings within. It is modeled after NASA's most recent triumph, Curiosity.
The Mars Science Laboratory, or Curiosity as it's now known, is the latest installment of the human invasion of Mars.
The Mars Curiosity rover is an amazing experiment. It has to look at a temperature extreme that goes from minus 200 degrees Fahrenheit to plus 100 degrees Fahrenheit. It has advances in mobility. There's no places that previous
That's a pretty wild temperature.
Sure. It took years to prepare tools for Martian exploration.
The instruments on Curiosity can be basically broken down into 3 different categories. Cameras, spectrometers that help us determine composition of the rocks and soil, and radiation.
Curiosity uses its cameras to pick out Martian rocks and soil specimens. Then its spectrometers zap the soil with lasers. The burning dust creates light that can be read.
The way we look at the abundance and elements of the universe is we look very carefully at the color of light. By analyzing that light, we can say quite a lot about the chemical makeup of stars and even sources of our planets.
Patty Bell says back at it again. It's basically all we ever do. Laura Linhart says, damn that Johnny Walker fire smooch. Patty Bell says, happy Thanksgiving. Happy Thanksgiving to you too.
To read our robot Ambassador with a diverse set of the most sensitive instruments, state-of-the-art motion sensors, temperature and gas gauges, elemental analyzers, and infrared cameras. Because we don't know what alien life will look like until we confront it.
We can't be blinded by detecting things that resemble life on Earth.
You can look for something that has good metabolism. You can look for structures that would be another indication that, you know, there's life there.
There aren't going to be any simple answers. There's going to be a lot of amazing surprises.
4 decades ago, 500 million people watched the Apollo astronauts land on the moon. Today, 5 billion tune in, hovering around any available screen to see what happens.
Try to go to scene 2. Scene 2 should have it as the big one.
2, 1.
Yeah, it would be
For almost 3 weeks, we lived with.
Is it a new IP or the same one? Okay.
While its progeny spread like a plague across our.
See, it's weird. The only thing I can do to get it to come back up is restart, but I can't do that in the middle of the screen.
Sending an unknown probe to pry answers from the monster's graph.
Yeah, I know, it's really wild. It almost did. We're actually live through, the other tab, yeah. No, we're still good. Maybe tried to start a whole new scene. That's what I did with scene 3, was to just try to start a whole new scene with it. But I still don't know, because I've tried all of that.
Think about the early explorers of planet Earth, people like Magellan.
Try to go to it in the browser and see if it pulls up.
These people set out into the unknown. If we're going to continue
Green
on
lights flashing.
indefinitely, we have to do this. Our survival is on.
Is the firewall blocking it?
Why is the state of Texas?
Try a different. We try a different.
Very, very, very thin.
Yeah, that's what I was originally going over here.
The idea being that you use the pressure of the sun's rays.
Downstairs. Well, see, that's what I'm saying. Maybe it could be the firewall.
Probably wouldn't do that.
I don't know though.
I can see what's wrong. Downstairs.
The rover sends back stunning views of the ship as it hurtles over 17,000 miles an hour in orbit above us. Then, a frightening discovery. Mounted on the ship's side are 2 6-mile.
You could just paste it and then take off that excess that we have on the end.
It may have weapons considerably more advanced, weapons that could destroy a planet. It could rapidly explain why there are so few Earth-like planets in the galaxy now, because of earlier waves of warfare.
The facts are that any society that actually could come here, whatever they want to do, they're going to be able to do it. To think otherwise would be to assume that the Neanderthals could have defended themselves against the U.S. Air Force. They could try.
These apparent cannons are aimed at the sails, not Earth.
Once you get a certain distance away from the sun, that drives the solar sail. There are theoretical designs for solar craft that can be powered by lasers that are under the craft.
At the moment, there are no lasers pointed at us.
Do you have any other cameras? Maybe it's the camera.
I don't think I think it's your computer.
Landing on a moving target.
I really do.
When landing the Curiosity rover on a red planet, NASA's engineers had to aim for an object orbiting the sun at over 53,000 miles per hour.
Think of a quarterback trying to hit his receiver. If you throw the ball where the receiver is, you miss it because the receiver's moved on. So you have to know where the planet's going to be and leave the planet with your spacecraft.
For the Ambassador rover, the challenge of sticking the landing on the mothership will be even tougher.
The spacecraft doesn't have the gravity of Mars. It doesn't have an atmosphere to dissipate velocity. So you would literally have to match speeds with the spacecraft and somehow would fix your spacecraft to it and then go.
The world watches breathlessly as the Ambassador matches the speed of the mothership and positions itself along the flank. It scouts for a place to land and attach itself.
The sprawling alien mothership has invited Earth's emissary, the Ambassador Rover, inside. I'm always amazed in science fiction where the alien spaceship is enormous and consists largely of empty space. Of all of the impractical things to put in an interstellar craft, empty space is probably the least practical.
It might look like the tunnels and burrows of the ground, or it might have hexagonal honeycomb spaces that would give a very efficient way of dividing up space.
The interior of an alien ship, you're not going to be able to understand it. It might work in a whole other way with the thing on top of it. That's the real
As the first image is coming, you see a giant mechanical puzzle.
One of the problems we have when we send rovers into the world hoping to find life is that it's very hard to say what life is. You know, it's life is not good.
Is the entire ship a single machine?
puberty, moons must fall within the gravitational reach of their parent planet. One of these orbits is known as the heliosphere. This phenomenon is named after George William Hill, an American astronomer from the mid-1800s.
So a heliosphere is this region around the planet that moves along with the planet.
For some reason, as soon as we started the stream, the second camera stopped working, Laura. John is making mushroom pendants. He said that's a true artist at work. Patty Belton.
Faster than the moon, like Venus, the higher force between the two actually shove Venus out further and further. Phobos, on the other hand, is rotating faster than Mars rotates.
These small moons were discovered by American astronomer Ashley Hall in 1870.
Yeah, no, it started working at first. And then as soon as we went live, it froze up. So I tried to refresh it. And it just stopped working.
Tom Duxbury was part of the Mariner 9 mission that first photographed the two potato-shaped moons in November of 1971.
This was late at night, a cold, rainy, dark, dreary day. I looked at this and I turned the picture sideways. It looked like a skull. And it was such an eerie thing.
Phobos is in a death spiral. It orbits just 3,700 miles from the Martian surface, closer to its host planet than any moon in our solar system. If our own moon is close to the Earth as Phobos is to Mars, it would look 20 times larger.
Its orbital period would be hours, not days like it is now, but hours. And that full moon, it would fill the sky.
Daily highs rise and fall tens of feet, hundreds of feet, and so the Earth's moon would eventually crash into the Earth in such a situation.
Phobos' predicament is caused by a process known as circular acceleration. As Phobos races faster than Mars rotates, a tidal wave is raised on the Martian surface. In the process, Mars yanks Phobos closer to its surface with each orbit. The struggle between Mars and Phobos is similar to the dynamics of the simple game of tetherball. Imagine the ball as the moon, the pole as the planet, and the world between the pole and the ball is the planet's gravitational pull.
What we see is that the gravity will pull the moon in such a way that it speeds up. It goes faster and faster, and it works its way into it. Eventually hits the pole. That's exactly what's happening to Phobos. Phobos is going around Mars faster than Mars rotates. That tidal interaction is pulling Phobos in closer and closer and speeding it up with its orbit. In about 50 million years, we expect Phobos to be pulled in so closely it will impact Mars and disappear as we move to Mars. On the other hand, Deimos, the further out moon, is going slower than Mars rotates, and so it's unwinding the string in the opposite way.
If that moon crashed into Mars, would it like push Mars closer to us or something?
I don't know.
Propel it out of its
Because it would change its mass slightly too, so it would be a little bit heavier.
Mars will become moonless.
Those are like architecturally there.
Because Phobos outpaces the rotation of Mars, it appears to rise in the west and set in the east.
Instead of the planet turning quickly under like our most other moons, and thus having it rise in the east and set in the west, it races ahead of the rotation of the planet, and so it comes up on the western horizon and races ahead and sets on the eastern horizon.
It will be another 50 million years before Phobos completely disappears. prove useful for the eventual colonization of Mars. Science fiction writer Arthur C. Clarke speculated on this idea in his book, The Sands of Mars. Although there was no real reason to colonize Phobos itself, its close proximity to Mars makes it a natural base station.
From a gravity standpoint, it's much easier to go into Phobos, which has no gravity, than it is to fight the gravity of Mars to get down to its surface.
From Galileo to Stanley Kubrick, the giant planets of the outer solar system have tantalized our imagination very remotely. But in reality, exploring them is tantamount to suicide. The overwhelming pressure from Jupiter's massive atmosphere will make it almost impossible to function. But the moons of these behemoths may provide a more promising platform for exploration and even future colonization. Are these prisoners of Jupiter's gravity, hostile worlds with little chance of sustaining organic life? Or might they provide a safe haven for future generations of planetary explorers? Until recently, very little was known about the moons of the gas and ice giants. Most of them remained in the deep red planets. Today, modern telescopes and unmanned space exploration reveal a realm populated by most moons, from planet-like spherical worlds to misshapen ones barely 30 miles across. Jupiter, the largest planet in the solar system, is a room planet. Nearly 4.5 billion years ago, it began as a massive gas cloud collapsing in on itself. This process, known as accretion, formed the beginnings of the Jovian system. While nearly all the gas and spinning material went into forming Jupiter itself, a very small percentage clumped in small eddies within Jupiter's orbit. These miniature accretions solidified into Jupiter's regular moons, Io, Europa, Ganymede, and Callisto. As Jupiter coalesced, its massive gravity began adding to its menagerie, little remaining bits from the birth of the early solar system.
The giant planets formed early in a gas-rich environment when there was lots of little flotsam jetsam around the solar system still to be captured in orbit.
The number of Jupiter's moons ranges from 60 to over 200, depending on who's counting. What's clear is, if you could stand at the edge of Jupiter's gaseous atmosphere and look to the heavens, you'd see a magnificent dance of lunar objects.
It would look pretty cool to be able to see the moons. Every so often you'd see Io come by. Every second time Io comes by, you'd see Europa at the same time. And every 4 times Io comes by, you'd see Ganymede.
One member of this Jovian cast is so packed by Jupiter's great mass that it's literally bursting from the inside out. In February of 2007, the New Horizons spacecraft, eventually bound for Pluto, focused its cameras on Io. About the size of Earth's moon, it is 263,000 miles from Jupiter's surface. What sets Io apart from the other Jovian moons? This is spectacular volcanism. New Horizons cameras captured detailed photos of glowing lava scattered across Io's surface. A huge 200-mile-high dust plume rose above the surface of the molten moon. Io, like all Jupiter's regular moons, is named after a lover of the god Jupiter from Roman mythology. It was discovered by Galileo in 1610, first photographed by Pioneer 1 in 1974, and again by Voyager 1 in 1979. Its pulsating activity has puzzled and intrigued scientists for decades.
Leaving Io is about a ton per second when you do it. Every second of every day. It's a phenomenal machine.
I would like to go to Io, even though it'd be very dangerous and hot and sulfurous.
Io is too small to have maintained a molten core since its formation. Another mysterious process must be responsible for its heating.
Its entire interior is molten because it's squeezed so much that there's no room for action.
This process is known as tidal heating. The massive gravity of Jupiter is causing friction at the inner core of Io. Much like a sculptor kneads a cold lump of clay, Jupiter is endlessly creating its own masterpiece.
If the moon gets a little bit of tidal heating, it becomes malleable and is stretched out like clay, formed by the gravity of the parent planet. The surface of the moon is cold, it breaks, like pulling the clay apart quickly to avoid it. But the interior, where it's warm, can literally flow and stretch, needed by the gravity of the parent planet.
Most regular moons have circular orbits. To produce tidal heating, a moon must be in a more oblong orbit, where the distance from the host planet changes rapidly during a single revolution. The only way to produce these eccentric orbits is if another moon's gravity disrupts it.
When the moon is in an eccentric orbit, non-round orbit, it gets closer and farther from its parent planet. When it does, it gets squeezed, it gets pulled apart when it's closer.
Io is in orbital resonance with its companion moons, Europa and Ganymede. While Jupiter and Io struggle to find a synchronistic relationship, Europa and Ganymede are taking Io in opposite directions. Jupiter yanks back, and Io gets stretched and squeezed in the process. The tidal heating on Io, which is responsible for its prodigious volcanoes, has a secondary side effect. It creates the largest stationary visible object in the solar system, a massive gas cloud 500 times the size of Jupiter. In 1990, Professor Michael Mandillo and his team from Boston University discovered a large gas cloud spanning the huge distance from one side of Jupiter to the other. They were the first to photograph the entire nebula, discover its origins, and the mechanism that keeps it growing.
Now, Io is small, it doesn't have much of an atmosphere, but these volcanoes are continually providing material that could be an atmosphere. But you might ask, well, why does it have a tremendous atmosphere with all the volcanoes that are going on for eons? Well, it's because the material is scarce.
The key gas is sodium. Even though it only makes up 5% of Io's injected materials, it's easily detectable by telescopes on Earth. Sodium emits an orange glow. In fact, sodium is commonly used to illuminate streetlights in many cities across the world. The sodium and the other gas molecules are pelted by light from the sun and electrons in Jupiter's powerful magnetic field. Electrons and protons knock off some of these particles and ionized. Now in plasma form, these ions are taken on a ride by Jupiter's powerful magnetosphere. Its speed increases dramatically because it's been picked up by the magnetic field. It's like they're taking a ride on a cosmic carousel.
The magnetic field lines are the poles here, and then every now and then, sodium atom gets picked up along with the electrons. And now I'm in the Jupiter plasma core with all the other ions and electrons that have been captured previously. And the ions and the electrons recombine, the nucleus is not defined by the magnetic field, and it goes off at a much higher speed. And that's enough to escape from Jupiter. And they form the largest visible cloud of gas equivalent of the indigo.
If we could see the nebula with the naked eye, it would be the size of 12 moons in the night sky. It is so enormous that to view it, Mandillo and his team created their own specialized telescope.
Well, as it turns out, to get a big field of view, all you need is a small lens. The tail of the magnet gives you a big field of view.
Even in 1991, the telescope may have seemed ordinary, but its camera was highly sophisticated and, at the time, revolutionary. The digital camera.
Watching funny pictures at the moment, you can do all kinds of things.
Cadillo and his team knew that sodium existed in the nebula. Sodium also exists in the Earth's atmosphere. They were able to compare digital photographs of both Jupiter and Earth's atmospheres and bring forth an intertube